This is a potential difference problem. Remember, potential difference can also be referred to as voltage. And these types of questions are actually pretty difficult because conceptually the idea of potential difference or voltage is kind of a complicated one, a very subtle one, and it's not easy to understand. So I'm going to try and take you through it as best I can. Okay, so the problem reads, if it takes plus 1.6 times 10 to the negative 5 joules of energy to move a positively charged particle between two charged parallel plates, then A, what is the charge on the particle if the plates are connected to a 6-volt battery? And B, was it moved from the negative to the positive plate or from the positive to the negative plate? Okay, so to help us visualize it, I would like to sort of show this in a diagram. Here are two parallel plates. They'd probably be conductors, so you can imagine like two rectangular pieces of aluminum placed a little bit apart, and then we have like a 6-volt battery. And what we could do with that is just connect the terminals of the battery to the two different plates. So the positive terminal of the battery, you could just connect with a wire to that plate with a clip. With the negative terminal, you could do it to the other plate. And then what happens is, because of this battery voltage, you start getting positive charges all over this plate and negative charge all over the other plate. And usually these plates are separated by a certain distance. Now, in order to make life a little easier for us, I'm just going to redo this diagram. I've just tried to redraw it now from as if we were looking at it on the side. I just picked the top plate to have the positively charged plate and the bottom plate to have the negative charge. No rhyme or reason. I could have easily flipped it. It's not going to matter. Here, with this diagram, let's try and solve part A. So the formula we know is that the change in potential energy is Q times delta V. Now, in this case, delta V is going to be 6 volts. And we know our potential energy is 1.6 times 10 to the negative 5 joules. We know it's a positively charged particle, and you can see you can just solve for Q here. So Q is just going to be this delta UE over delta V, and when you do that, you're going to get 2.70 times 10 to the negative 6 coulombs, or 2.7 microcoulombs. Let's look at part B. So part B asks, was it moved from the negative to the positive plate or from the positive to the negative plate? Okay, so this one's a little more conceptual. We don't have to do any math. The idea that it being a positively charged particle that's going to be moved between the plates, the fact that we have to put energy in. So just to give you a little background here, since delta UE is positive, we would have to add energy to the positive charge to move it between the plates. Okay, well, notice if I put the positive charge right here, it's going to automatically repel from the positive plates and start being attracted to the negative plate. In other words, if I just leave it on its own, it's going to just move. This positive charge Q is just going to automatically, without doing anything else or putting more energy in, it's just automatically going to start moving between plates. But because this problem tells me I have to put energy in, that means I have to do work to get that charge to move between plates. So if I start the charge here, you can see it's going to be attracted to the negative plate and repelled from the positive plate. So if I leave it here, this charge is just going to stay right where it is. In order to move it to basically go against the repulsion of the positive plate, I'm going to have to add energy in to this. You can imagine reaching down with your hand, grabbing this positive charge, and basically, because it's being repelled from the positive plate and attracted to the negative, you would have to physically push or pull that charge to get it to move closer to the positive plate. You'd have to put energy in and increase its potential energy. Therefore, because we're given that the change in potential energy of the charge is positive, we'd have to put energy in. Q would have to be being moved from the negative plate to the positive plate. So the answer is Q would have to be moved from the negative plate to the positive plate. All right, if you have any questions about this problem, please feel free to let me know. Send me an email or get into contact. I'm happy to go over it with you. Thanks for watching. Have a great day.